Welcome back. In this video, you will learn about multiplying and dividing radicals with me, Changster. We will be using the product and quotient properties of square roots to help us. If you can't remember the properties, I've listed them here. If you want to have a better understanding on how these properties work, please refer to my earlier videos on evaluating radicals and simplifying radicals. So let's get to some examples and see how we can apply them. In our examples, we will be looking at how to simplify square root radicals. Once you have understood how it works, you can apply your understanding to cube roots and radicals of higher index. In example 1, we have 4 square root 2 times square root 3. We can apply the product property of square roots to simplify this product of the two radicals. So from here, we can write it as 4 square root of 2 times 3, and that gives us 4 square root 6. If you remember from my previous video, square root 6 is called an irrational square root and also known as absurd, and it cannot be expressed as a fraction. And the part in 4 is our rational part of this expression, because 4 can be expressed as a fraction. It's like 4 over 1. And of course, square root of 2 and square root of 3 are also surds or irrational square roots. In example 2, you have to simplify 4 times square root 7 times 2 times square root 7. I can apply the commutative property of multiplication, meaning that you can switch the numbers around and they are still equal. You can write it as 4 times 2 times square root 7 times square root of 7. And in this case, the rational parts will give you 4 times 2 will give you 8, and square root 7 times square root 7 is equal to 7. So the answer for example 2 will equal to 56. In example 3, again we can apply the commutative property of multiplication to multiply the rational parts together and then the radical parts together. So you can see that 3 times 4 will give you 12, and 2 times 18 can be now written under the radical sign, and you get 12 times square root of 36, and the principal square root of 36 is equals to 6, so you get 12 times 6, and the answer is 72. In example 4, we are looking at square root of 7 times square root of 42. 7 is already the most simplified radical, so let's look at what happens to 42. 42, I can divide 42 by, say, 2, I get 21, and I can divide 21 by 3, I get 7. So you can see that there's a 7 under the radical for square root of 42 that you can use to multiply with square root of 7. So let's see what I mean here. So from here you can write times 7 times 6, and I can break it up now. Square root of 7 times square root of 7 times square root of 6. Of course, square root of 7 times square root of 7 will give you 7, so the final answer is 7 root 6. Now I would like to recap the property that we are very familiar with. We know that square root of b squared is equals to b, and of course it's the absolute value of b. But for the situation like square root of 7 times square root of 7 is equals to square root of 7 squared, therefore is equals to 7, and we don't have to put it as the absolute value of b. That's why we have these two examples. Square root of 7 times square root of 7 is equal to 7. Now let's look at some examples involving fractions or division of the radicals. So for example 5, we can rewrite it as the square root of 4 over 9 times 18 over 4. And you can now use your knowledge on fractions to help you simplify this product. 4 divided by 4 gives you 1, so these two kind of like so-called cancel them out to give you 1. And 18 and 9 are both divisible by 9. So 18 divided by 9 is 2, 9 divided by 9 is 1. So the answer for this will be just square root of 2. In example 6, it is a product of two radical terms, so you can now just multiply the radicand together. So you get 3 over 7 times 14 over 27. And now apply your knowledge on fraction to help you simplify this. 3 and 27 are both divisible by 3, so you end up with a 9 in the denominator here. And 14 and 7 are both divisible by 7, so you end up with the square root of 2 over 9. And we can apply the quotient property of square roots to simplify this further to give us square root of 2 over square root of 9. And the principal root of 9 is equals to 3, so the answer is square root of 2 over 3. In example 7, it is a quotient of two radicals, so we can apply the property of the quotient of square roots to help us. So square root of 18 divided by square root of 6 is equals to square root of 18 divided by 6, and that gives us square root of 3. Example 8, we have the square root of 3 and 3/7 times the square root of 2 and 1/3. So we can apply what we learned in the earlier 3 examples or to help us. So it will be helpful to write our radicand under the radical symbol as improper fraction. So 3 and 3/7 it written as 7 times 321 plus 324 over 7 times square root of 3 times 2, 6 plus 1, 7 over 3. Now you can apply the product of radicals or square root property to help you combine the two of them. So you get 24 over 7 times 7 over 3. So, and then now you can simplify. 7 divided by 7 is 1, and 20 divided by 3 is 8. So you get square root of 8. And think about square root of 8. Can it be simplified further? We know that 8 can be written as the product of 4 times 2. So we can definitely simplify square root of 8 into a more simplified root. So you get 2 root 2. For my next 3 examples, we are looking at the product of a monomial and a binomial. Expressions with 2 terms are called binomials, and expressions with 1 term are called monomial. And also we're looking at the product of numbers and variables. So things are getting interesting. For the next 3 examples, we have to multiply and assume that all variables represent positive real numbers. So in this case, we don't have to think about whether or not to put the absolute value around the variables, because we know that they are all positive real numbers. Example 9, we have to find the product of 7 times 6 minus 2. So in this case, 6 minus 2 is made up of 2 parts. This is the rational part, and square root of 2 is the irrational part. And the thing is that you can't add the 2 terms together because they are so-called unlike terms. So you have to now think about maybe square root 2 like a variable. So you will have to kind of like distribute 7 to square root 2. So you get, so it's like a small rainbow and a big rainbow here. So 7 times 6 minus 7 root 2. So the answer will be 42 minus 7 square root of 2. Now again, there are two terms here. One is a rational term and one is an irrational term. So that's the answer. You can combine them further. For example 10, square root of r times 5 minus square root of r. So again, we will have to apply the distributive property to simplify the expression. So square root of r times 5 will give you 5 square root r. That minus square root of r times square root of r. So you get 5 root r minus r. And again, square root of r is an irrational term. You can combine it with r. So that's the final answer. For example 11, it is a product of two terms, two monomials. So for this example, you will have to multiply the rational terms together and the irrational terms together. So we can multiply 3 by negative 2, and we can multiply b squared by a, and you end up with negative 6. And of course, you get square root of a squared and square root of b squared. So in this case, the answer will be negative 6ab, and we will know that a and b are positive, so there is no need for you to put the absolute value sign. Let's look at one more example. Let's call it example 12 before we look at the quotient of the radicals. So example 12, 3 square root 6k squared times negative 5 square root 12k cubed. So from here, I can start to simplify the radical terms if I want to, or multiply the rational parts together. So I can first of all write 3 times negative 5. I'm putting the two rational parts together, and write square root of 6 and square root of k squared times square root of 12, which can be rewritten as 4 times 3, times square root of k cubed is square root of k times square root of k squared times k. And from here, 3 times 5 gives me 15, negative 15, and then square root of 6 is by itself, and I can now simplify square root of k squared to give me k, and square root of 4 is equals to 2, square root of 3 is equals to square root of 3 times this equals to k times square root of k. Let's put all the rational terms together. So we have negative 15, k and a 2 and a k here. I can rewrite them as negative 30 and k squared, and we have a square root of 6 times square root of 3 and square root of k. And from here you can see that 6 can be simplified into the product of 3 and 2. So I will continue writing it as, so I have negative 30k squared and square root of 2 times square root of 3 times square root of 3 times square root of k, and this gives me negative 30k squared times square root of 2, and we know that square root of 3 times square root of 3 would give me 3, and that times square root of k. And now if I combine the rational terms together, I'll end up with negative 90k squared, and I would have to multiply the two irrational terms together, and that would give me square root of 2k. It's pretty complicated, right? Let's think about how we can write radical expressions in different ways. For example, if I have square root of 5 divided by square root of 7, you can see that the denominator here is square root of 7, and it is an irrational number. So what I'm going to do is that I want to write it in a different way without changing the value of this expression. So I know that I can multiply this by, say, square root of 7, because root 7 times root 7 will give me 7. But I can just multiply this by 1 over square root of 7 because I'll change the value of this expression. So I'm going to multiply it by square root of 7 times over square root 7. So in this case, the numerator, I can write it as square root of 35, and the denominator becomes 7. So now this expression has got 7 in the denominator, and this is a rational number. I can eliminate the radical term from the denominator by multiplying a radical expression by an appropriate value of 1, because square root 7 divided by square root 7 is equal to 1. So this process of expressing square root of 5 over square root of 7 as square root of 35 divided by 7 is called rationalizing the denominator. As you can see, it is easier to name the decimal value of square root 35 over 7 than of square root 5 over square root 7. Of course, with the calculator, it may not matter. Now you will have the chance to practice rationalizing the denominator. You shall assume that all variables represent positive real numbers. In example 13, we have 3 over square root of 5. The denominator is a third, so you will have to rationalize it by multiplying. And you can do so by multiplying another square root to it, such that it turns into a rational number. And we know that from our earlier example, one way is to multiply square root 5 by square root 5. In order for us not to change the value of this expression, we have to make sure that the part in blue is actually equal to 1. So in this case, the numerator we get 3 square root of 5, and the denominator is now 5. So I have now rationalized the denominator, and this is my answer. In example 14, we have 4 divided by 3 times square root of 2. And in this case, some of you may be wondering whether you need to multiply the denominator by 3 square root 2 to get rid of the square root here. So do you need to multiply by 3 square root 2 in the denominator? You can do that, but it's making things a little bit more complicated. So all you have to do is to think about the radical term that you can multiply by our radical term here, so that you can rationalize the denominator. So I'll end up with, so you can do 4, 3 root 2, and all you have to do here is to multiply by square root 2 over square root 2. So in this case, the numerator, you will get 4 square root 2, and the denominator, you end up with 3 times 2. So in this case, I get 4 root 2 over 6. And is this the most simplified answer? You can see that 4 and 6 can be divided by 2 to give you 2 over 3. So the most simplified answer is actually 2 square root 2 over 3. In our example 15, you have the square root of 7 divided by 8. There are different ways to rationalize the denominator. Some of you may want to multiply by square root of 8 over square root of 8 right away. Some of you may want to simplify the denominator of square root of 8 to make it simpler. It's up to you. So I'm going to try just multiplying the numerator and denominator by square root of 8. So in this case, it has to be square root of 8 and then square root of 8. So I end up with square root of 56 over square root 8. And now think about whether you can simplify square root 56. Is it in the most simplified form? And 56 can be broken down into, let's see, 56. I'm going to do the work here. 56, I can divide it by 4, and that gives me 14. So I can break down 56 into factors of 4 and 14 over 8. So, and if I simplify that further, I get 2 square root of 14 over 8, and that can be simplified into square root 14 over 4. For number 16, 5 square root 48 divided by square root of 39, I find that 48 and 39 are large numbers. So what I'm going to do is that maybe just try to apply the quotient of square root to help me simplify the two numbers. So 5 times square root of 48 over 39, and we know that both numbers 48 and 39 can be divided by 3. So 48 divided by 3 is equals to 16, and 39 divided by 3 is equals to 13. So from here I end up with 5 times square root of 16 over square root of 13, and I want to rationalize the denominator, so I multiply by square root of 13 over square root of 13. So I end up with the numerator. I'll get 5 times 4 square root 13 over 13. So the answer will be 20 square root 13 over 13. In example 17, we have 4 divided by square root of 3n, and in this case I would have to multiply the denominator by square root of 3n and the numerator by square root of 3n to rationalize it. So I end up with 4 square root of 3n over 3n, and that's the answer. Before we go, I would like to give you the rules for simplifying a square root radical. An expression having a square root radical is in simplest form when no integral radicals has a perfect square factor other than 1. For example, if you have square root of 8, it is not in the simplest form because 8 has a perfect square factor, which is 4, and this can be rewritten as square root of 4 times 2, so you can rewrite it as 2 square root 2, and now this number 2 only has 1 as the perfect square factor. So number 2, no fractions are under a radical sign. So if you have, for example, square root a divided by b, so make sure you break it up using the quotient property of radicals so that you can simplify all the radical expression in the numerator and in the denominator. Number 3, no radicals are in a denominator, so this is what we talk about when we talk about rationalizing the denominator. So make sure that when you have a square root 2, and then make sure that you multiply by another radical so that you can get rid of the irrational term in the denominator. We have reached the end of my video. Thank you for watching, and don't forget to subscribe, and catch you real soon. Goodbye.